In this problem, we're going to find the final position of a particle given its velocity equation and the initial condition of s of 0 equals 9. Our strategy will be that we will take the initial position of the object and we will add to it its displacement, and that will give us our final position. So we'll start off with finding our displacement. Our displacement will equal the integral from 0 to 1 of v of t dt, which equals the integral from 0 to 1 of t squared minus 8. And instead of writing over t plus 1 squared, I'm going to write t plus 1 to the negative 2. This will make finding my antiderivative a little quicker. And as I go to do that, that will be then 1/3 t cubed. And we add 1 to the exponent, get negative 1. Negative 8 divided by negative 1 is positive 8, and it'll be t plus 1 to the negative 1, and that'll be from 0 to 1. Plugging in the upper bound, we get 1/3 plus, and that'll be 8 over 1 plus 1, which is 8 over 2. Subtracting 0 plus 8, and that'll give us 1/3 plus 4 is 4 1/3, minus 8 will be negative 3 2/3, and that will equal our displacement. Okay. Now we take our initial position of 9 and add to that our displacement of negative 3 2/3. We will get 5 1/3 for our final position after 1 second. So now to find the displacement from t equals 0 to t equals 5, that'll be the integral from 0 to 5 of v of t dt. And the antiderivative we already found on the first example is 1/3 t cubed plus 8 over t plus 1 from 0 to 5. Plugging in those numbers, we will get 125, that's 5 cubed over 3, plus 8 over 6, which is 4 over 3. Subtract, plugging in a 0, we'll get 0 plus 8. And when we add these all up, we're going to get 129 over 3. Subtract 24 over 3, giving us 105 over 3. This will equal 35. And so our final position after 5 seconds will be equal to the initial position, which is 9, plus the displacement, which is 35. So our final position is 44 centimeters. You could write a position equation, s of t then, to be the integral from 0 to t of u squared plus 8 over u plus 1 squared. That was our velocity equation. Du plus the initial position of 9. In exploration 1, we're asked to take the same problem we just did and look at it slightly different. We're still given the same ds dt, the velocity, equation, and we're asked to find the solution to the initial value problem. In this case, we're just going to say that s is equal to 1/3 t cubed plus 8 over t plus 1. That's what we found in the last, when we did it before, when we took the integral. And then we're just going to say plus c. And then we're going to put in the fact that s of 0 equals 9. So we plug a 9 in for the position when t is 0, which will give us 0 plus 8 plus c. So c will equal 1. So our position equation, s of t, will equal 1/3 t cubed plus 8 over t plus 1, and then plus 1. And now if we want to find what s of 1 is, we can just plug in a 1. We'll get 1/3 plus 4 plus 1, which is 5 1/3, and which is what we got when we did it before. If I want to find now s of 5, I just plug in a 5, and I get 1/3 times 5 cubed plus 8 over 6 plus 1. So and this will equal 125 over 3 plus 4 over 3 plus 3 over 3, which equals 129 plus 3 is 132 over 3, and 132 over 3 is 44 centimeters, which is what we had said before in the previous problem. So this is a different way of looking at it.